This final question of the second journal is a little bit more complicated in the sense that they have a square root there, and it's on the bottom, and it's like on the denominator. It's like, what do I do with that? Well, a couple different things that we can do to start with. I have that 3 outside the bracket. I'm going to leave it alone for a second. And if I look at the square root of any number, that's the same as it to the power of 1/2. Okay, so the easiest thing to do would be to change our 5a squared to the power of 1/2. Okay, so that got rid of that square root, but all of that is to the power of 3. Okay, so this is as complicated as it will ever get for you guys. So now I have these power to a power, what's going on here. So the first thing I will do is, and I'm going to switch colors, is I'm going to take this 1/2 and bring it into everything in here. So that's going to be 5 to the 1/2, a to the 2 times 1/2 is the number 1. And all of that, remember, is to the power of 3. So I end up with 5 to the power of, remember, everything has to be multiplied by the 3 halves, and a 1 times 3 is 3. So I'd be happy if you could get it to that. Now, I'll be perfectly honest, you could go a little bit further with this one if you so wished, because that is the same as going 5 cubed, which is the same as, oh, sorry, that should have been a 2 here, the square root, and that's the same as 25 times 5, right? Because there's a 5 squared in there as well as another 5. And I know this 25 is the perfect square, so that could be 5 square root 5. So if I put that back into my equation, I could write down 5 square root 5 a cubed. But as I said, I would be ecstatic if you could just get it to this point. Okay, excellent.